Today we are going to focus on two things. Number one, about the priority. We set priority 0, but I cannot set priority 500. The default priority is 32768. You can change the priority. We saw yesterday we put priority 0. There was no problem. The command was accepted. But if you try to give a number like 500 or 100 or priority 1, 2, 3, 4, it won't accept. Why? We are going to see that. Secondly, without giving the priority value, there is a way to make a switch as a root switch that will also impact on priority, but you will not set the priority. I repeat, you will not set the priority to change a designated switch to be a root switch. To change a designated switch to be a root switch, in the previous class we set priority lower. We can achieve the same result without giving a value. By doing some configuration, impact will be made on priority, but we don't give priority in a straightforward manner. Yes, there is a command called primary and secondary. The primary command will make a switch with low priority. Secondary command will make the switch with low priority but little higher than the lowest. So there are two ways in setting priority. One, you give the value, but you cannot give any value. There is a specific numbering method you need to follow to set priority. As I said, you cannot set priority 500. You cannot set priority 2000. So there is some procedure to follow to identify the priority value that we can set. There is also another way. Instead of setting priority directly, we can simply use the keyword primary and secondary. When I say primary on switch 2 for VLAN 10, 20, 50, that becomes the root switch. How? By making the priority smaller than the other switches. When I go to switch 4 and say primary for VLAN 30, 40, 60, switch 4 will become root switch. Again, same priority is reduced than any other switch to make this as a primary. Secondary will be used if you want that switch to be a backup for some other switch. For example, switch 4 need to be a backup for 10, 20, 50 VLANs. So I'll configure secondary for 10, 20, and 50 on switch 4. All right, so this is the first topic that we are going to deal with. The second topic will be rapid spanning tree protocol configuration and considerations. All right. So two things. First, let us see priority. You see, I'm going to switch to and I say spanning tree for VLAN 10, yeah, 10, 20, 50, right? 10, I'm saying priority 500. See, it is not accepting. It says the bridge priority must be the increment of 4096. It needs to be the increment. See, you can use 0. We used it in the previous class. Or it should be the increment of 4096. When you double 4096, you get this. When you double this one, you get this. Sorry, when you add 4096, keep adding 4096, you get this, you get the default is this. You can go higher also. Add 4096, you get this. Add 4096, you get this. That is what we call as increment of 4096. So when I configure 2000, it won't accept. But when I configure 4096, it accepts. Let me show you. Show spanning tree VLAN 10. You see 4096 plus the VLAN number, that becomes 4106. So what have we learned here? There is a specific allowed values. There is an increment of 4096 value allowed. And you see, maximum you can go only up to 61440. Now, two things you need to learn here. First, why should be increment of 4096? Why not priority 500, 600, 700? Why it is only 0 or 4096 or 8192 or 1228 or 1638 or 2048 Why? Why? That we need to learn. Secondly, why it goes only maximum 61440? Why not bigger than this? All right, these are the questions that should be in your mind now. And I'm going to answer these questions. Do you all have this question in your mind? Yeah. So let us see the answer for this. Now, 2 to the power of 12 is what? Can anyone say? 4096. We need to understand. Why not some other number? Why only this sequence? Why it is only increment of 4096? You see, there are 16 bits in the bridge ID. The higher order 4-bit is what dedicated for priority. If you notice, priority is nothing but the priority plus the system ID extension. For that system extension, system ID extension, which is nothing but the VLAN, you have this 12 bits. Totally 16-bit. Starting from 2 to the power of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes. This is for VLAN. So how many VLANs you can have? 2 to the power of 12, because when you calculate number, decimal number, you will say 2 to the power of this as the first bit. So totally how many bits you have? 12 bits. Why maximum you can have only 4096 VLANs? Because you got 12 bits. 2 to the power of 0 to 2 to the power of 11. How many bits? 12 bits. Fine, that is one side. So you can have VLAN from 1 to 4096. This is one important thing that we learned. Why VLAN is not more than this. Now, for the priority, if you see, starting from 2 to the power of 12 to 2 to the power of 15, which is the 16th bit, given, in which by default, these priority bits are 0 and this is 1. What is 2 to the power of 15? Can anyone find and tell? Darshan? Nice to hear that. Though you come late, you had internet issue. The default is 30768. The increment is 4096. We learned it. So when I try configuring some other number other than this order of increment by 4096, I'll not be able to do that. I'll not be able to give 100. It clearly says what numbers you can use. Then why is maximum 61440? Yes, that's what you will get, no? When you make all these bits on, I'll write here 1, 2, 3, 4, 2 to the power of 12, 2 to the power of 15. If all these bits are on, the face value of this is 4096. The face value of this is 8192. The face value of this is double 16,000. Can anyone calculate? What is 2 to the power of 14? 384. And this is 32768, we know. Now you add and see all this. You will get this as the maximum. You cannot go more than that because you got only 4 bits. Higher order 4 bits. You cannot go more than that. Right? I answered this now. 2 questions. Number 1, why increment of 4096? The other one, why default is 32768? And the other one is why the maximum 61440? If any question, you ask now. Okay, if no questions, what I'm going to do is I'm going to cancel these priority commands that we configured in our previous class. I'm going to cancel them. And I'm going to show you another way of configuring the same. Now, I canceled here. I would like to cancel on the other switch as well. Okay, I cancelled, and now you know what will happen. Only this will be the root switch, and there will be a block here for all the VLANs. Let's wait for that. You already see there is a amber, which means this is blocking for all VLANs. Let's check. This is no more a root switch for any VLANs. Show VLAN 10, show spanning tree for VLAN 10. This is blocking. You see that? BLK. This is not a root switch. 20 blocking. 30 blocking. You see here, I'm showing this one. 40 blocking. 50 blocking. So the only path available now for all VLAN is the upper path. We are going to achieve the same result that we received through setting priority like this. But this time I'm going to do by using the primary and secondary keyword. So what I will do is I will say priority primary. Whereas for VLAN 30, 40, and 60, this will be root secondary. So the keyword is not priority, the keyword is root. I want this first switch, which is on the top, I want this switch to be the primary for VLAN 10, 20, and 50, whereas the below switch will be primary for VLAN 30, 40, and 60. And for VLAN 10, 20, and 50, this will be root secondary. What does that mean? Active and backup. That's what it means. You see, this VLAN 10, 20, 50 will go this way. But if this link fails, I don't want any other switch to become a root switch except this. So this will be become the root switch for 10, 20, and 50. That's why I said secondary, so that no other switch will get the chance of becoming root switch, even if you have multiple paths. You got only 2 paths now. Let's say 3, 4 paths are there. And now when the first path goes down, I want only the second path to be the backup, not the third or fourth path. So you can configure secondary. Now what literally happens is, when I say secondary, the keyword secondary, from the default 32768, 4096 is deducted, subtracted. What is the value? Can anyone subtract and tell me? 32768 minus 4096. 2867. Sorry, it's 28672. Now, when I say primary, what happens? From 32768, 8192 will be subtracted. 2, 4, 5, 7, 6. You see, this is lower than this. That's why this switch will become this switch will become root for 10, 20, and 50, whereas this is going to be the backup because I said secondary, it gets 4096. I mean, this gets priority 28672, 28672, and this gets 24576. So now all other switches have got 32768. So you don't need to care about those switches. Only these two switches you need to compare. The upper switch have got small priority compared to the below switch for VLAN 10, 20, and 50. And below switch have got smaller priority than the upper switch for 30, 40, and 60. That is how this becomes root switch. Did you understand this? Just by giving the keyword primary, you can achieve this. When you say primary, big number is subtracted. When you say secondary, comparatively small number is subtracted. When you subtract small number, you will get big number. When you subtract big number, you will get small number. How many of you did not understand this? Now we are going to see this. Let's go see this. You see, I'm going to make this switch as a root switch for 30, 40, and 60. See how I do. Right now, for 30, 40, and 60, is it 30, 40? Yeah, 30, 40, and 60. See, for 40, it is not a root switch, it is blocking. The priority is default. But now when I say spanning tree for VLAN 30, 40, and 60, root, you see the keyword? I'm not using the keyword primary. I'm not using the keyword priority. I'm using the keyword root. In the previous class, we set priority and we gave a value. But this time, I don't want to give a value. I want it to auto-calculate. So I say the word root and you see two options, primary and secondary. I'm saying primary and see what happens. Ready for it? See. This is what we calculated. You see? When you say primary, you will get this value 4, 2, 4, 5, 7, 6. 2, 4, 5, 7, 6. Also for 30, no? See, 2, 4, 5, 7, 6. Plus. Also for 60, no? See? 2, 4, 5, 7, 6. And this is the root switch. Now, for other VLANs, let's say for 10, if you see, this is still having 32768, but I'm going to make this a secondary. Before that, let's go to the upper switch and make it as primary for 10, 20, and 50. The upper switch should be primary for 10, 20, and 50. Spanning tree, you can put all the VLANs together like this, 10, 20, and 50. Root primary. Spanning tree for VLAN 30, 40, and 60, root secondary. Here I'll say Spanning tree for VLAN 10, 20, and 50. This is the below switch, huh? Root secondary. Okay. Now when you say secondary, it subtracts just 4096. So when you subtract 4096 from 32768, you should get 28672. Yes, 28672. Did you understand now how the primary and secondary helps us to achieve the root switch election? Everyone? Okay. Rapid spanning tree protocol. The one which we have seen so far is slow. Both common spanning tree protocol, which is IEEE 802.1d, as well as the Cisco proprietary protocol per VLAN spanning tree, they both are slow. The reason for their slowness is timer based. The other reason for the slowness is not every switch will be sending BPDU. Only root switch will be sending BPDU. So when something goes wrong in the topology, the BPDU won't reach. That will make the other switch to know there is something wrong with the link. But it will hold for 20 seconds. Every 2 seconds, BPDUs are sent by the root switch. Say, for example, let's say this has got lower priority, sorry, lower MAC address. Switch 1 will become the root switch. Do everyone agree? Yeah. So this will be designated to forward, designated to forward. Now, what switch 2 will do, it will make this port as a root port because this is the low cost port. Going like this is very costly. So to reach root switch, this is the best port. And this is the root port. This is root port forwarding. Likewise, this switch will also try to find the cheap cost path to the root switch. But here, both the paths are same cost. You see 19, 19. Here also 19, 19. Same cost. So what it does is it prefers to go via the neighbor whose bridge ID is lower, whose MAC address is lower. So this will become the root port. Every switch should have a root port. If this is root port, then this cannot be blocking. So this will be designated forwarding. I repeat, there is a root port, all other port will be designated forwarding. Root port, designated forwarding. Whereas here, this will block. Why? The MAC address is bigger than this one. And this is designated forwarding. Any questions so far? The previous examples, we had only 3 switch and 2 switch. We did not see this example, so I'm asking you, do you have any question in this, what I have explained now? All right. So if you take a switch, it should be a root switch to forward all the port, to have a designated forwarding on all port. If it is non-root switch, it should have one root port at least and a designated port or blocking port. If you see here, it has got root port and blocking port, root port and designated forwarding port. Blocking port is nothing but alternate port, root port forwarding. Saravana, are you comfortable? Okay. Mhm. Now, let us now talk about the timer. In normal classical IEEE 802.1d and per VLAN spanning tree protocol, which is Cisco, only root switch will be sending the BPD. And that BPD will come this way, so it understands I need to block and it will keep blocking this port. Blocking for what? I've said this many times, it won't block BPDU. The BPDU sent from this link will be coming to this switch via the other link, even when there is a block. That only makes this block to continue. So BPDU will not be blocked, but the user traffic will be blocked. User traffic will be blocked. Now, to unblock this when there is a link failure, it takes 50 seconds. We saw that live yesterday. We lose a lot of packets. For example, if this link goes down, the BPD which was coming from this direction will stop coming. Only this direction BPD is coming, but this direction BPD is not coming from root switch. So this will wait for 20 seconds, and then it says, okay, I noticed a topology change. Even this guy will also say, my directly connected link has gone down. We need to wait for 20 seconds and do something for this. So every switch is now waiting for 20 seconds. After that, they say, root switch is dead, let us do re-election. Let's do topology discovery. Let's learn. That's what called as learning. Now every switch now starts sending BPDU to decide who will be the root switch. And now they are sending BPDUs, they are learning the new topology. Now for this new topology, they start learning MAC address. Sorry, initially they were listening for 15 seconds. And now it learns all the MAC addresses for the new topology, that is another 15 seconds. Already 20 seconds gone for the timeout. So 50 plus seconds it takes for this switch to unblock so that the traffics will go this way. Earlier traffic was going this way. Because there is a block, it cannot go downward. But now there is a need for a downward because the link has gone down between switch 2 and switch 1. For that block need to be removed. To unblock, it takes 50 seconds. Timer based. But that is not the case with the rapid span tree. In rapid spanning tree, the port roles are not classical. In this common spanning tree and per spanning tree, you had listening port, learning port, forwarding port, block, also one more discard. Wait, it should be there down written somewhere. Yeah, disable means you can shut down. You had this 5 port roles in normal spanning tree, whereas in rapid spanning tree you have only this 3. This disable, listening, blocking, all 3 called as discarding, meaning no traffic will be allowed in that port. No traffic will be allowed in the port. So no learning, no listening, no blocking, no disable. It is called as discard. One word, discard. No listening mode. You will not see this listening. You will see learning and then immediately forwarding. No timer based. You have discard, which means that's a blocking port. No traffic supposed to go there via that port except the BPDU. Learning, as soon as this link fails, immediately this guy says, no waiting for 20 seconds, because every switch can send BPDU in this rapid spanning tree. Very important point. Every switch can send BPDU. In the previous 2 cases, only root switch is eligible to send the BPDU. Here, every switch can send the BPDU. Now, this guy says, hey, the direct link has gone down. Topology change. Boom. Every 2 seconds, it is coming. So this guy immediately learns this new topology from this incoming BPDU and unblocks. Immediately. Just in 2 seconds, notification comes and unblocks. So only learning and forwarding. You know what is root port? The port that takes you to the root switch. You know what is designated port? The port that will forward. Root port will be a forwarding port. What is the alternate port? If in case the root port goes down, the alternate port becomes the root port. You see here in this diagram, this is designated forwarding. This is actually designated. But if this link goes down, this will become the root port. And this will become the designated forwarding. And this will become the root port. Because this is the root switch, all will be turning towards this direction. Backup port, a backup port for the designated ports. Designated port will turn to a backup port whenever the topology change appears. So these things, these are all automatic, just port roles, names. Now, rapid spanning tree, if you are connecting between 2 switches, that link is called as point-to-point link. Only if it is a full duplex. When you run rapid spanning tree between switches, the full duplex link between the switches are called as point-to-point link. You can see that here also, though we don't have enabled a rapid spanning tree, it is common for all spanning tree. Right now it is running per VLAN spanning tree. Let's go to the other switch. Show spanning tree, you see, you can see P2P, point to point type. Link type is point to point. If you are connecting to a computer or a server or any end device, it's called end port. If you are connecting to a switch with the old half duplex link, it is called a shared link. These are all link types in RSTP. Point to point means full duplex link between switches. Edge port means the port that connects to the end device where the BPDU will not be coming. Will there be a BPDU coming in the edge port? No, because you are connected to a computer. Can a computer send a BPDU? No. Can a computer respond to a BPDU? No. They are called as the end port. Whereas point to point is not like that. They send the BPDU, they receive BPDU, they get response to the BPDU, they get the topology change notification. You should know the difference between this edge port and point to point. Point to point is between the switches. Edge port is between the switch and the end device. Other thing that you should know from rapid spanning tree in today's classes, there is only 3 states: discard, learning, forwarding. Discard is equal to blocking, learning, and forwarding. Learning doesn't take much time, less than 2 seconds, boom. It makes the blocking into forwarding. It makes the discarding into forwarding. So rapid spanning tree is very fast in convergence because they do not wait for the root switch BPDU to time out. Every switch can send BPDU. When there is a change, they start negotiating and then they change their port role. They're not timer based. We call this as proposal and agreement mechanism. See, as soon as this link goes down, this guy is sending a proposal. Hey, link has gone down. The topology changes happened. And the other guy agrees and immediately changes that blocking to forwarding, or the discard to forwarding. Direct failure detection. If a root or a designated port fails, rapid spanning tree quickly switch to the backup alternate or backup port. It makes the alternate port into forwarding port. That's what it means. Very fast in convergence because every switches can send a BPDU. It's not timer based. Sending that new topology change notification is what called as proposal and agreement mechanism that makes rapid spanning tree faster. You see, bridge hello mechanism. Instead of wait timer to expire, rapid spanning tree sends only BPDU every 2 seconds to detect the failure. Every switch is sending that so they can detect that failure very fast and make the blocking to forward. All right, I'll stop here. We'll continue this theory one more time in the next class, followed by the lab of rapid spanning tree. Anyone has got any questions?